Each Thursday during the summer, from the first week of May to all the way to Labor Day, we're out testing the water at 28 popular swimming holes on the Coosa River. So each Thursday in here, it gets pretty crazy. I'm going to show how to do one sample, but multiply this by 28 each Thursday throughout the summer, and that's what we're dealing with. So each week, when our samplers come back, they will have all their samples in this Whirl pack. And in this Whirl pack, there's sodium thiosulfate tablets, which kind of like hold on to the chlorine just in case we're testing at a wastewater treatment plant. That way the chlorine doesn't end up killing the bacteria more and more and more in the sample. So they come back in these guys, and then our lab intern will pour the sample water from the cooler into a 100 milliliter bottle, like so, and then pour in an enzyme. So the reaction of what we do is a very, very easily readable test, which is not a really common thing in the biology world, because you're thinking like using microscopes, but we don't use any microscopes. We use our naked eye to count all of these wells. So to do that, we need this enzyme, which is Call Alert 18. And Call Alert basically changes the appearance of the organism that's in the bacteria, but it doesn't change the quality of it. So that way, if E. coli is invisible to our naked eye, now it's making it visible. So we break the enzyme into the water. And then we shake it up. And then we put it into these trays. So these are called quanta trays. And a bunch of biologists that are much smarter than I am did a bunch of serial dilutions to come up with a most probable number for the bacteria. So when we pour the sample into here and then have it sealed, it's evenly distributed throughout this tray. So each sample, when they come out of the sealer, will look like this when they go into the incubator. So it's still a completely clear reaction. We can't tell at this point if there's any total coliform or any E. coli in there, because the enzyme hasn't had its full reaction time to complete, which is 18 hours. So on Thursday, we put all of the samples in our incubator and then take them out on Friday morning and then have the results out by 12. Now, when they come out of the incubator, they look like this. So they will completely change color if there's total coliform, which total coliform is kind of like the umbrella above E. coli. So you can't have E. coli without total coliform, but you can have total coliform and not have E. coli. So typically with river water, we're going to expect that there's going to be a high amount of total coliform due to it being a natural environment. And that's good, because you don't want to have a system that doesn't have any bacteria in it, because that means that there's a chemical in the water that's killing all of the bacteria. So it wouldn't really be a safe place to swim in anyway. Just like your gut, it's healthy to have bacteria. It's healthy to have bacteria for a natural environment. One thing that is not healthy is to have E. coli. Now, E. coli is naturally occurring in the large intestines of warm-blooded mammals. So what that means is it's a fecal contamination indicator. So basically there's poop in the water. And we all know that with poop comes other diseases. So the higher amount of E. coli that's in a sample, the higher likelihood that you could get sick with any of the other diseases that come with fecal contamination. Over here, we have Tucker, who is reading our results that are going to come out today. And pretty interestingly, the total coliform will be yellow, but the E. coli glows. So this is a pretty cool part of the reaction that makes E. coli seem like the coolest that it'll ever be. Under a UV light, it's glowing. So that's what Tucker's doing right now, is he's counting the wells that are positive for E. coli. And as he counts those wells, he will use this quanta tray table to determine how much colony-forming units of bacteria is in 100 milliliters of the sample. and we use that. We use the state's data to determine whether or not that's green, safe to go swim, yellow, proceed with caution, and then red, you probably shouldn't get in the water, based on how the state says what's safe or not to swim in E. coli.